Okay, let's look at an example of using dynamics of motion. So we have a father places a 20 kilogram child on a cart to which a rope is attached, then holds the end of the rope and spins the cart and child around in a circle, keeping the rope parallel to the ground. If the tension is 100 newtons, how much time does it take for the cart to make one rotation? Okay, so the first thing I'm going to do is just list what we know here. So let's see, the mass of the child, I'm going to put a kid, so a K, that way I don't have two C's, is going to be 20 kilograms. The mass of the cart is 5.0 kilograms. And then there's a 20-meter long rope that's attached to it. So what we have is we're going to have like here's the center, so dad's standing there, and then we have a rope attached to the cart, and then and the cart and the kid, and then this is moving around in a circle. I'm really bad at drawing circles, so you'll be all right. So spinning them around, so that rope is the radius. So the radius is going to be 2.0 meters. All of my units are good. Holds the end of the rope, spins the cart in a circle, keeping the rope parallel with the tension in the rope. So the tension in the rope is going to be 100 newtons. All right. And what we want to know is we want to know the period. How long does it take? Not to be confused with tension. That's why we put the vector. So this is tension, this is period. So since he's spinning, there's some velocity coming around in this way. There's some radial velocity or tangential velocity. So we have velocity. Since it's circular, we're going to have centripetal acceleration coming this way. And since I have centripetal acceleration, I'm going to have a centripetal force as well, which is acting towards the center. Now this is if we're looking from the top, and one thing you have to be concerned with circular motion is looking at it kind of edge on. So if you imagine that here's dad holding the rope, and this is parallel to the ground. I know that's a bad picture. And here's the kid in the cart. What we want to do is analyze the forces from a edge on view. So it's kind of moving in this plane. So if I had a coordinate system like this, it's moving along in the X direction, not in the Y. But it's moving out of the page into the page, out of the page into the page. So along this Z component, but don't worry about that. What we want to do is we want to look at the forces. So we have some weight here, and the weight is offset by the normal force. And so all of my forces in the Y direction, the sum of the forces in the Y is going to be 0. So it's only the X direction. So what's moving this way, and that's just the tension. So that's my centripetal force. So my net force in the X direction is going to be the tension force, or the centripetal force is equal to the tension. All right. And it's this that we'll use in order to figure out what's going on. So let's come over here and I'm going to work. So we want period. To get period, we can think about velocity. So velocity in circular motion is just 2 pi r divided by the period. And I want period, so I can rearrange this. I get that the period is going to be 2 pi r over velocity. All right, I know the radius, but I don't know velocity. And to get velocity, maybe we could use the acceleration. So going back to this, the centripetal force, or the tension, the centripetal force is equal to the tension. But centripetal force is equal to mass times centripetal acceleration. All right. So now I'm just going to work with this. We can drop the centripetal force. So we just have the tension is equal to mass times, changing this into terms of velocity. So v squared over r. And now what I can do is we can solve for, let's solve for v, and then we'll see, and we'll plug it back in here, and then maybe we can figure something out. So to solve for v, I would multiply by r. So I would get tension times the radius, and then divide by the mass. And then that would be equal to v squared. So to get rid of the square, I'm going to take the square root. And that will tell me the velocity. Okay, so I can plug in my values. So the velocity is going to be the square root of 100 times r, which is 2, divided by the mass. Now the mass here is going to be both of these, so we need to divide by, what, 25 kilograms. So we'll divide by 25. And we get a velocity of about 2.83. I'm using the numbers in the book, in the text, so that it'll match when you go back and look at it. All right, so now I have the velocity. Well, now we can just take the velocity, plug it back in there, and we'll get our period. So the period is going to be 2 pi times the radius, which is 2 divided by 2.83. And we get a period of 4.4 seconds. Okay, so there you go.